All right, so now to actually implement that here in our sim. So let's go back over to the fracture world here. And our rotors, basically we've already attached our rotor blades to the mechanical stuff in the middle. So it's the mechanical stuff in the middle that actually needs to be constrained. So now the question becomes, what to constrain it to? For this, I like to kind of make my own little bit of helper geometry. So what I mean by that is I'm just going to make a tube here that's basically not going to be seen. But we'll attach this little tube, or whatever. It doesn't need to be a tube, but it helps to think about it as a tube, I think. Just make this small little polygonal end-capped tube, which looks like this. And I'm gonna actually come back to this for a second. I wanna see this. Let's go to the top view of this. So go to set view, top viewport, and it's this tube here that I want to position. In fact, let me do the opposite. Let me view this and then template that. So in the, this is always tricky with Houdini. I want to get the manipulator here. I don't want the scale one. Turn this off. There we go. So I'll just go with the T for translate. And then we'll go down to this little magnet with a dot that will help us snap to points. So what I want to do is snap it to this point right in the middle here, right in the center. Because when I modeled this, you know, I didn't have the rotors necessarily at right down the middle. So in fact, as we can see, the z-axis, it was just a little bit ahead of it. So coming back out, I press space 1 to go back into perspective mode, or you can just choose it here. Turn this snap to point back off, and I just want it to be more or less underneath it. It doesn't really matter. Again, it's not going to collide with it. Just something like right there. Let's give it a name, because everything should have names, or everything needs names, especially if there's a constraint on it. I'll call it /mount, because everything is in terms of /something in this name hierarchy. And that's it. I'm going to merge it right before we actually turn these things into packed geometry. I'm going to say merge that in, so now this is our whole mechanical rig. And that will be what gets turned into these packed pieces, packed fragments, as it were. So cool. So that works. Now I want to pull it back out again. Now that it's in that form, I'm going to say, let us be in point selection mode. So S2, and click on this guy here. I guess I'll click on this first. I need to be in point selection mode because now that these are packed primitives, the name attribute is now at the point level, which is weird and annoying, but that's how it works for some reason with Bullet. The point is, I want to isolate. So I'm going to click this. I'm going to say, let's get our mount thing here. You can see it's selected there. And this one's a little weirder. I want to get the ring there. Next up. Delete non-selected, and there you go, we have it. That could be a little tricky to do. I wanted to do it that way because I wanted it to be in terms of name equals blah, 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 blah. If you have trouble pulling that off, you honestly can just say, click this, and you can just be in primitive mode, and you can just click it more directly like that. Or you can literally just click them here and click delete. So now they're in terms of just their primitive number, which is less robust, but you could do that. I just like doing it in terms of the name. It just feels a little bit more secure. These numbers could change theoretically upstream, you know, if we change like what's getting split where. But at any rate, we have these two, and as we just saw in our demo, I'm just going to use like regular connect adjacent pieces. And I'm going to make the radius large enough that it finds them. It doesn't really matter how large because there's only two pieces. We just need it large enough that it finds them. We want that length attribute as we just saw. Very cool. I also want to, before I forget, I should put this in a group. I'll call it section rotor mount. Just like here we had rotors mechanical, I guess I'm calling it rotors. Because later we're going to need that to stitch it back onto the rest of the helicopter. So cool. So now we have our thing here. We saw before we need to do a prim wrangler. It's a constraint name equals pretty much exactly what we just did. I also need to spell this right. Constraint type. Now, there's actually going to be more stuff that we do here than before, but this is enough to get us started. So we just want to merge that in with the constraints that we already have. So take the constraints to here, add that in. So we went from that to that. And that's going to be the constraints that get put into our cool rig thing. Great. So it'll be a lot easier to test all this stuff if we aren't working on the entire helicopter at once. Let's at least get our mechanical thing to rotate on top of that base. So that was kind of, I think, the thinking here. Because this is all kind of one sub-asset, let's just pass that on. So again, not the entire helicopter. Now our RBD thing here, the thing that actually ends up going to the sim, is just going to be that. Cool. So let's go over to our sim. We can see it's rotated just that into place here. Probably going to need to change that initial position, which is why we talked about that so long ago. But while we're here, let's go ahead and add the cone twist. So cone twist, we already know that we want this to be 0, 0, and 180. We know that this needs to be called cone twist. We can also already see how we're not going to be able to just put the right vector in here to make this work, because it's not y equals 0. Or rather, x and z equals 0, y equals 1. But nonetheless, we should at least be able to see it show up. So I'm going to say turn off this guide geometry, and there it is. So these two lines here pointing in that direction that we have on here, x 1 1 0 0, that's what they're doing. It is at least showing up, so that's good.